Hi and welcome back. This tutorial we are going to discuss about the PID controller. The PID controller is really useful when programming the robot. Its purpose generally is when part of the robot is in one state or position and you want it to get to another specific state. You can use the PID controller to get there in a very efficient and precise way. Okay, so let's go deeper to what is the PID controller, and it will help us to understand when we're programming later. So the PID controller contains three arguments. The first argument is the P argument. It's here. The P is for proportional. This is the formula for this proportional argument, and what it says is some constant called P times the error. Now let's define what the error is. The error is actually the wanted state minus the current state. So if I'm let's take an example. If I'm in 30 degrees and I want to get to 90 degrees, so the error is 60 degrees. So this is the error, and it is changing through the time. This is why the symbol here is E error as a function of the time. Okay, the second argument is the I. I is for integral. It sounds pretty scary, but it actually doesn't. Let's draw a graph of E as a function of t. So let's say we're here, and here is our 60 degrees error. We are at 60 degrees, and now we're coming to 0. So this is 0. When our error is 0, it means that we are in a wanted state. Okay, integral, if you know a bit calculus, is the area under the curve. So here, this is the area. And this means that we're taking the area under the E as a function of t curve. If we are now in this time, t1, so from 0 to t1. So this is a constant times the area under the curve. And what's happening is as the time grows, this argument will go larger. Last argument, the D argument. D is for derivative, and also it's a bit calculus. When we have this graph, so the derivative of a graph is the slope in each point. So for example, we are taking this point, it will be like this. Okay, so you can see that the graph is very slopey, so derivative will always be minus and very low. Okay, so all of those arguments are added up and they're the output. The output is the thing that will get the current state more closer to the wanted state. So the proportional grows proportionally when we are far away from the wanted state that is here. So the P argument will be larger, and then the output will be more larger, and we will get closer to the error. The I, as the time passes and we still not in the wanted state, the output will be larger. And the derivative is actually to delay the time to get to the error, because if P and I will grow very large, it could be a situation that the function is just passing over the wanted states, and then we are now have minus error. So the div argument purpose is to make this graph less sloppier. To sum it up, we can say that the P argument is for the present because it's regarding the current error. The I is for the past because it's regarding all the previous errors, which is the area of the graph. And the D regards the future because it is regarding the slope, and it tries to prevent the PID controller from passing the error without stopping. Okay, so now let's go to the wind river and see how we can program it. Okay, so now let's do a quick example of the PID. We want, I don't know, arm that will turn around 90 degrees. So we have a motor and a potentiometer, and the potentiometer tells us the angle which the arm is. So we'll create a potentiometer which is analog and a motor. Let's say that 90 degrees are from 0 to 1 voltage. So we need to initialize it. And we also need a PID controller. So let's create it. The PID gets 5 parameters. The first 3 parameters are the P, I, and V constants. We'll set them as 0 because we don't know the appropriate value. And the next value is the PID source, which is the input for the PID, and this is the potentiometer, and it wants a pointer. So, and the last parameter is the PID output, which is our Jaguar, and it should also be a pointer. So now we can set the set point, which is the state we want to get to. And we want to give it a value of 1. And also we need to set the output range, because the motor can get only between -1 and 1. Okay, now we can use it. When the button joystick will be clicked, we want the PID to be enabled. And we want the first button. If it's true, we want to enable the PID. And now the output will continuously be set into the motor. If we want to know when to disable the PID, we need to check if it's on the target. You can also set the percentage of the PID, which will be considered as on target, because it probably wouldn't be precisely on the target. This function called set tolerance, and we are writing 3%.